Hey guys, so we made it through our first week. Everybody did well, and hopefully we'll continue to do well. A couple of things I want to talk about is first, please go back and look at the comments that I am writing on your work each day. So I always go through and check it, give you comments, things of that nature. If I don't have Fridays up by now, it will be up by this afternoon. So please go and look at those. This Friday, we are having an open note test that will be timed. Okay? And so you need to be preparing for that. Make sure you get everything together, and we'll be reviewing later on in the week, but it will be over everything on quadratics. So we'll talk more about that. This is kind of our last lesson on quadratics. So Friday, we looked at solving a nonlinear system with quadratic function and linear by graphing them. And some of you expressed that it was a little bit difficult to see maybe where those points were. So I'm going to show you another way to do that, and that's by doing it algebraically with substitution. So instead of having to graph it, how about plugging one function into the other and seeing where they're the same? So I'm going to go through some examples on that today. Alright, so here we have these two functions. This one is quadratic. I know that because of the exponent of 2, and this one is linear. It doesn't have that, so this is linear. So if I want to know where they meet, I can graph them and see. Sometimes they don't always cross at whole numbers, so this is a way that we can see if they don't and how that we can solve for that. But even if they do, this is another way to solve. So with substitution, our first step is to solve for one of the variables in either equation. Usually you want to do that in the linear equation, but that's already done in both here. They're both solved for y. So our second step now is we're going to take what our linear is and substitute it in for y in the quadratic equation. So then we have 3x plus 1 equals negative x squared minus 1. So now we have just a quadratic equation to solve. And so we need to get everything on one side. You know I like to keep a positive, so I'm going to move these over. And so that's going to give me x squared plus 3x plus 2 equals 0. So now from here to solve it, I could either factor or use quadratic formula. I like to factor, so I'm going to do reverse FOIL. So that's going to give me x plus 2 and x plus 1. We'll multiply to 2 and add to 3. Set each one equal to 0 and solve. So I get x equals negative 2 and x equals negative 1. So that means that these two functions are going to cross at two different points, when x is negative 2 and when x is negative 1. So to find those points, when x is negative 2, so I'm going to take negative 2, and you can plug it in either equation. I'm going to use the linear one because I think that would be easier. And I'm going to solve for y. So that's going to give me negative 6 plus 1, which would give me negative 5. So one point of intersection would be negative 2, negative 5. Then I'm going to do the same thing for x equals negative 1. And so here I get negative 3 plus 1, which would give me negative 2. So the other point of intersection is at negative 1, negative 2. All right, another example. All right, so our first step on substitution is to get one of the variables by itself. What you want to do in your linear equation is solve for y. That's going to be the best way to do it. So to solve for y in this equation, I would subtract 3x, divide by negative 1, and get y equals 3x minus 9. Then you're going to substitute that into the quadratic equation. in this equation. So I'm going to get x squared equals 2 times 3x minus 9 plus 10. So then I just start working things out here. I get x squared equals 6x minus 18 plus 10 when I distribute. Combine like terms, and I get x squared equals 6x minus 8. I like to keep my a positive, so I'm going to move these over and get x squared minus 6x plus 8 equals 0. Now here I can either factor or use quadratic formula. I'm going to factor. So this is going to factor into x minus 4 and x minus 2. So we get x equals 4 and x equals 2. Then we're going to do like we did here to solve for our y values. So for x equals 4, now you can use this equation, this one, or this one. I'm going to use this equation because I feel like that would be the easiest to solve for y. So I plug in 4. 3 times 4 is 12, minus 9 is 3. So one point of intersection would be 4, 3. And then I'll plug in 2. I get 3 times 2 is 6, minus 9 is negative 3. So the other point of intersection is at 2, negative 3. So if it's not solved like this one is for y, find the linear equation and solve for y first. Take what y equals there and substitute it into the quadratic equation, and then solve your quadratic equation. Then take those x values. You may get 1, you may get none. Okay? You may get some kind of error. We're not going to do any of those today. And then you plug that back in and solve for y to get your points of intersection. So today I've got a Schoology assignment where you're going to do that, but you will also have to upload your work to go along with that. So you'll pick your answer on there, but you also have an assignment where you upload your work like we did the other day. Please, please, please message me for questions. I have sent you a message about my phone number because I am doing a lot more work at home. They're not making us come into school now, so you won't be able to call the school. You can message me on Schoology. You can send me a message if you'd like to take a call or FaceTime, and I can do that with you. And then also I have on here, I want you to join my class on Khan Academy, or to, I know a lot of you already do that for geometry, so I've put the code on there for you to do that, or if you're not on Khan Academy, how you can sign up for that. So please do that after you complete your assignment. So have a good day.